Have you ever wondered how we measure the height of a mountain or the angle of the sun without even touching them? Welcome. Today, we'll learn the basics of trigonometry, the math of triangles. The word trigonometry comes from Greek. Tri means three, gon means angle, and metron means measure. So trigonometry simply means measuring triangles. Trigonometry is everywhere, in engineering, architecture, physics, and even astronomy. It helps us find distances, heights, and angles that are impossible to measure directly. Let's start with a right-angled triangle. The longest side is called the hypotenuse. The side opposite the angle theta is the opposite side, and the other side is the adjacent side. Remember the right-angled triangle we looked at earlier? Let's bring it back. Trigonometry is built on three main ratios: sine, cosine, and tangent. Sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. To remember them easily, use the phrase soch, chi, koch, toa. We've learned the three main trigonometric ratios, sine, cosine, and tangent. But there's more. Each of these has a reciprocal partner, cosecant, secant, and cotangent. Let's see how they're related. Cosecant is 1 over sine, that's hypotenuse over opposite. Secant is 1 over cosine, hypotenuse over adjacent. And cotangent is 1 over tangent, adjacent over opposite. Let's take a right-angled triangle with sides 3, 4, and 5. Opposite 3, adjacent 4, and hypotenuse 5. Can you find the sine, cosine, and tangent of angle theta? Sine theta equals opposite over hypotenuse, that's 3 over 5, which equals 0.6. Cosine theta equals adjacent over hypotenuse, 4 over 5, that's 0.8. Tangent theta equals opposite over adjacent, 3 over 4, which equals 0.75. In the same way, you can find the reciprocal ratios, cosecant, secant, and cotangent, using the formulas we discussed earlier. Now, how do we find the angle theta? Let's use the sine value we found earlier, which was 0.6. Move sine to the other side of the equation and use a calculator to find the angle. The result is theta equals 36.87 degrees. Let's summarize. Sine, cosine, and tangent link an angle with the sides of a triangle. Remember secant, toa, and their reciprocals, cosecant, secant, and cotangent. Here's a real-life example of trigonometry. A person standing 1 meter tall looks up at the top of a lighthouse. The angle of elevation is theta, the height above eye level is h, and the distance to the base is bc. Using the formula tan theta equals h where bc, we can find the lighthouse's height, showing how trigonometry helps measure distances without climbing. Let's consider an example of this lighthouse to find its height. A person stands 20 meters from a lighthouse, and the angle of elevation to the top is 30 degrees. Using the formula tan theta equals h per bc, we substitute the values, tan 30 degrees, h per 20. Solving gives h is 20 times tan 30 degrees, which is about 11.5 meters. Adding the person's 1 meter height, the lighthouse is roughly 12.5 meters tall. That's the beauty of trigonometry. It connects angles and distances everywhere. Keep practicing your trig ratios, and soon they'll become second nature. If you found this helpful, don't forget to like, share, and subscribe for more math magic.